you all are invited because you're doing the new version of functional skills, which is called the reformed functional skills. Doesn't really matter what they are. They're the same level of qualification as they've been for many, many years. And there are some not massive changes. Probably the biggest thing in maths is that during the test, you will have questions where you can't use a calculator. So you have 15 questions at the start where you can't use a calculator and 15 questions at the end where you can use a calculator. The topics are exactly the same, so you could come across probability or ratio or fractions or volume or anything like that in either section. Just, as I say, you're not allowed to use a calculator. Because of that, the calculations are usually, the numbers are a little bit more straightforward, as in they're not as messy, for want of a better word, calculations, but you do still need to do them. So you will need pen and paper and to work out figures. You might be able to do it in your head and whatever. And one thing we've realised with people doing this test is the maths might be absolutely fine, but it's a long time since they did adding up, taking away, times or dividing on a piece of paper. So I'm going to run through that now. Some of it may be really basic. You might sit there thinking, well, that was really obvious, I got that. Some of it may come back very quickly, go, oh yeah, that's how you do it. Another may be a completely new method to you. I do know in schools nowadays they teach some slightly different methods as well. So if I go through something and it's slightly different to your method, then that's fine. You're welcome to use your original method or mine. Or if you've got kids at school and they want to show you a completely new, wonderful method, then that's great as well. You can use whatever's right for you. With the non-calculator section, the first 15 questions, you don't usually get marks for showing you're working out. There's usually 1 mark per question and you get the answer. Sometimes there's more than one because there's a couple of stages to it. But usually it's about getting your answer and say you don't need to show you're working. The second section, you do get marks for working. So that's the purpose of today, and that's what I'm going to talk through. One of my favourite phrases when it comes to maths is there's only 4 things you can do in maths. You can add up, you can take away, you can times, and you can divide. Can't do anything else. It's all about how you do them, when you do them, what order you do them in. So I'm going to go through adding, taking away, times and dividing, and say some people call it long addition and long multiplication, or very different words as well. But I'm going to talk through the methods that I would use if I was doing it on paper. And I'm not going to give a scenario like you would get in the practice test, in the real test. I'm just going to give you some numbers and add them up. I'm going to try this with my mouse, and if that doesn't work, I'm going to try my finger on the screen. So hopefully you can all see the grid on the screen. And the first calculation we're going to do is just 17 add 94. The reason I've done it in a grid is just to show you that we can try and keep things in lines. That works for some people. If you've got some grid paper you want to take into the test, you're welcome to, but you may not need to. Just my handwriting is terrible, so I thought, especially on the screen, the grid would be better. So when we're doing addition, it's relatively straightforward. All we want to do is we want to keep these 2 sections, these columns as they are, and we want to add them up in the columns that they're in. So our first column is this one here, and so we should start on the right. So if we think about it, 1 and 7 is 10 and 7, 17, and it's 9 tens and 4 units, as you might call them, on the side. So we start on the right-hand side with our smaller numbers. So starting on this column, we've got 7 add 4, which is 11. And if you want to do that in, again, fingers and toes or in your head or counting, whatever it might be, that's fine. 7 add 4 is 11. We've only got space in this box here to put 1 number, and that is our second number 1 because it's our unit. So we need to carry the first one, the 10, over to this column. And the way I write that is I write that down here. Some people write it up here. I tend to write mine at the bottom. It's up to you which you do. We've now got in this column here, we're going to add up 1 add 9 is 10. And we've got another one to add on here, so that makes 11. We've only got space in this box for 1 number here. So for 11, we write 1 here and we write our other one here. So 17 add 94 equals 111. And all I've gone through is going to be in order. With addition, it doesn't matter what order you add things up. If you've got 7 numbers, it doesn't matter what you order them up, you'll still get the same answer. So let's say we had 3 numbers. So let's say we've got 123, add 16, add 498. And so I'm just coming up with these numbers at random. I'll put my equal sign. Always a good idea to put the plus, minus, divide, times on there, just so you remember what you're doing. And again, I'm going to add up in this column first of all. So 3 add 6 is 9, add an 8 is 17. I'll put my 7 in there and I carry my 1 over to the next column. If I do my next column, remember working from right to left, 2 add 1 is 3, add 9 is 12, and I need to remember to add on the 1 that I've got at the bottom, which gives me 13. So I'll put the 3 in there and carry the 1. And in this column, we've got a 1 and a 4 make 5, and a 1 that I've carried over at the bottom. So that gives me an answer of 637. And I have done these in advance and checked whether the answers are right. So, so you can trust me, they are. So 123 add 16 add 498 is 637. If you've got 10 numbers, you can either do them all in a row, or you might add 2 up and then add another 2 and then add another 2 and then add them all together, or you might do 5 in a row. It's entirely up to you how much you break it down. Obviously, if you put 10 numbers in a row and add them all up, it's a little bit quicker, but there's more chance you made a mistake. You miscount one number. If you add 3 up and then another 3 and then another 3 and then add them together, and that's 9 things added up, you're less likely to make a mistake. You may want to break it down that way. So that's addition. I'm going to go bottom left of the screen now. I'm going to do a takeaway, subtraction. So let's take the figure 536. Again, I'm going to put my minus sign there, my takeaway sign there, so I remember what I'm doing. Takeaway 94. So subtraction is very similar to addition. I'm going to go start from the right-hand column. I'm going to go to our left. And the first one is straightforward. 6 takeaway 4 equals 2. We can do that. So that's nice. We've now got a bit of a problem in this column, though, because if we look, we've got 3 takeaway 9. Well, 3 can't take away 9. That gives us a minus figure, and that's not what we want. So this is where there are a number of different methods you can use. The method I'm going to show you is I'm going to actually borrow one from this column here. So if we think about 536, that's 5 hundreds, 3 tens, and 6 units. So I'm going to borrow one of the numbers from the hundreds column to enable to give me an extra number in my column I'm using. So we look at this middle column. So I'm going to take one off there, which makes this 13. Because I've taken one off the 5, I need to remember that this is now 4. So I've now got 4 and then 13 and then 6. So if I just do that again to be clear what I've done, I want to take one off this column here. So I'm going to cross the 5 out. I'm going to write a 4. So I remember that I've got 4. Sorry, I put an extra line there that I shouldn't have done. So I remember that I've got 4 here, and I've carried that one over to my middle column. I've now got 13 take away 9, which is 4. And in this third column here on the left, I've got 4 take away nothing, which again is 4. So the answer to my original question is 442. So as I said, apologies if this is really basic and you say, well, I knew that, or if this is a different method to use, but this is the key, carrying one from the left-hand column, moving it over to my middle column to give me that answer. So that's addition and takeaway. One thing, incidentally, I'm going to give you send some practice questions out after this, so you will be able to have a go of all these things. So that's addition and takeaway. And I'll rub all this out, and then we'll do division and multiplication separately. Remember, if there's any questions, feel free to raise your hand, put your mic on, or put it in the chat window, and Eamon will keep a track of that and let me know. So let's look at multiplication, and we're going to do a relatively straightforward one to start with, and we're going to do 68 multiplied by 3. I'll repeat myself in that I've put that multiplication sign on the left so I remember what I'm doing. For multiplication, again, we work on a column at a time, but we work on this time we sort of keep the top row separate to the bottom row. See what I mean when I go through it. So my first column is 8 times 3, which is that column there. So I'm going to multiply those together. So 8 times 3 is 24, he says, yeah. Just double checking my maths there, keep you on toes. So we've done 8 times 3. We now need to multiply 6 times 3. So we're looking at this column here, but we're still multiplying by 3. So 6 times 3 is 18. I did this mistake earlier as well. 6 times 3 is 18. We had 2 at the bottom that we carried over, so we need to add those on. 18 add 2 is 20. So our total answer is 204. We did 8 times 3, and we did 6 times 3, but we carried a number over to make it 24. So similar to addition. Multiplication becomes a little bit more complicated if you have more than one digit on the bottom. So here we multiplied by 3, which makes life a little bit easier. This time we're going to multiply by 2 digits, 26. Okay, what we're going to do is when the 26 figure at the bottom, we're going to take them in 2 parts. So first of all, we're going to take the 6 and ignore the 2, and then separately we'll ignore the 6 and take the 2. So let's just look at the 6 for the moment, and we're going to do one column at a time again. So 1 multiplied by 6 is 6. And remember, we're ignoring 2 at the moment. So I've now got 4 multiplied by 6, excuse me, is 24. And so I write them like this. This is where the columns and my grid paper is particularly going to be particularly helpful. So we've multiplied by the 6, so we can cross the 6 out and ignore the 6. We're now going to multiply by this figure of 2 here. The key now, though, is to bear in mind that although that says 2, it's actually representing 20, because 2 and 6 is 26. So the figure is we're actually multiplying by 20. Although it says 2 on the screen, we're actually multiplying by 20. Hopefully you recognize whenever you multiply by any thing that ends in a 0, you will always have a 0 in your answer. So if you multiply by something by 20 or 30 or 40 or 50, it will always end in a 0. So we're going to put a 0 in our units figure because we know that's there. We can now go back and multiply 1 by 2. 1 times 2 is 2. And we also then need to multiply 4 by 2 is 8, which gives us a figure of 820. Just going to do that again. So we've multiplied by the 6 already, so we're going to ignore the 6. We're now going to multiply by the 2, but we know that that's 20, so we're going to put in a 0 to indicate that we've got no units. We now do 1 times 2 is 2, and 4 times 2 is 8. And now we've got these two figures, and we can add them together. 6 add 0 is 6. 4 add 2 is also 6. 8 add 2 is 10. So our answer is 1066. So 41 times 26 is 1066. We could have more than 2 numbers to multiply together. So one of the next maths webinar we're doing is on to do with shape and space and those kind of things. And one of the calculations you have to do is volume. So if you've got a volume of a cube, say like a swimming pool, to get the answer, you multiply the 3 sides together. So you might have 24 centimeters by 18 centimeters by 13 centimeters. You can multiply them in a pattern there, in all 3 together there, but it does get very confusing and very complicated. So if you did have more than 2 numbers to multiply together, what I would recommend is you multiply these 2 together. I'm not going to do this one, and you get a figure. And then once you've got your final figure, you then just times that by the other figure. I think I said 13, and then you get an answer here. So basically just do it in stages. If you had to multiply 5 numbers together, do the first 2, then multiply the next one, then the next one, then the next one. You won't have that level. I can't imagine they'll ask you to multiply any more than 3 numbers together. But if you do have more than 2 numbers, I would personally suggest multiply 2 numbers together first and get an answer, then multiply by any other numbers that you've got. One other thing to note on multiplication, and again, I'm just going to quickly talk through it rather than do a full example. You may be multiplying. So we've got here 41 by 26. So we've got 2 2-digit numbers. The top line doesn't really matter how many digits you've got. So let's have 267. And you may be multiplying by 100 and let's see if that. Oops, it's meant to be another 64. So what you would do in your first column is you would multiply everything by 4, and you will get your answers here. You're now going to multiply by 60. So we know that the answer is going to end in 0. So then you can do your multiplication here. Then you're going to multiply by the 100 figure, and we know that 100 ends in 2 zeros. So we're going to put 2 zeros in and then do your calculation here. So if you did get to multiply by 3 digits on the bottom, then you can just move along with these number of zeros. I'm hoping that makes sense because I've rushed that a little bit. The reason I've rushed that is I don't think you'll get any more than the figures that we've got here, where you've got sort of 2 figures multiplied by 2 figures. I don't think you'll get any more than that. You may get a third figure to multiply, but as I say, in that case, you would get to your answer here, and then you will multiply by your next figure underneath that. So that's long multiplication. I think probably a little bit more difficult than addition and subtraction, I would suggest, but hopefully that's been a useful little revision for you. Finally, I saved the best till last. Now, I said when I sent the email out, and I said at the start of this, that we don't tend to do long calculations on paper all the time. You may do if you've got a quick one, but we do rely, I think understandably, on computers. If you've got a calculation to do in our house and it's a big one, we'll sometimes ask Alexa and all those kind of things. So there's lots of options in the world now for doing calculations. Addition and subtraction and multiplication, I'm generally okay on. Long division, it's been a long time since I've had to do long division, or I did it on a regular basis, put it that way. So I'm quite happy to say that I had to check up that my methods I was using were correct. And I'm hoping they are, because I'm going to show you 2 of them now. So we may have a calculation, and again, I'm not going to put any context to it, where you need to do 96 divided by 2. Okay, for whatever reason, we want to do 96 divided by 2. Now, this is a fairly straightforward one, because obviously if you're dividing by 2, you're just halving the number. So we could just halve 96, but we're going to show a method to do it. And we're going to use sometimes called short division, sometimes called long division, because there's a couple of slightly different methods, sometimes known as the bus stop method. And the way we would do it is we would write our 96 here, and we will put 96 in a bus stop, and we'll put the number 2 on the outside. So 96 divided by 2, the key things there is the 96 goes under this sort of little archway or this bus stop or whatever you want to call it, and the number you're dividing by goes on the outside. The number on the outside will take as a whole number, and what we want to do is we're now going to work, previously we were working right to left, we're now going to work left to right, as you would read normally. So the first thing we're going to do is 2. How many 2's go into 9, or 9 divided by 2? Well, we can count up 2, 4, 6, 8. We know 4 2's go into 9. Now, actually, 4 2's is 8, so it actually gives us 1 left over here. So we've got 9 here. And we've done 4 2s, which is 8. So we've got 1 left over. So if we want to make it easy, we can cross out the 9. And we're going to carry our 1 over to our next column. We've now got number of 2s in 16. Again, you can count up, and that's actually 8. Now, 2, 8 actually makes 16. So we've got nothing left over, anything like that. So our answer now is on the top is 48. We'll just quickly go through that again. So we want to look at how many 2s can we get into 9? Well, we can get 4 of them. That doesn't actually give us 9, that gives us 8. So we know we've got 1 left over. So we carry our 1 to the next column. How many 2s go into 16? We can work that's 8. And we've got nothing left over. So we've got our final figure of 48. Okay, let's do a slightly more complicated one. And you might have 3 digits to divide by. So let's say we had a calculation of 627. Divide, oops, that's not a good line, is it? Divided by 3. Okay, remember we said in this time addition, subtraction and multiplication we were going right to left. We actually go left to right in this instance for division. So how many 3s go into 6? Well, hopefully you appreciate there's 2 3s go into 6, and we've got nothing left over because they go nicely into 6, so we don't need it. We now need to look at how many 3s go into 2. Well, 3s obviously don't go into 2 because there's more, so we actually got 0, and we need to carry the whole of that 2 over to our next column because we haven't used it. We can put any 3s in there. So we've got 0 3s go into 2. We carry it to the next column, which is 27. 3s into 27, I can tell you, is 9. And if you're unsure, you can do 3, 6, 9, 12, 15. You can count them up on your fingers. Again, fingers and toes or a bit of paper is fine. And that gives us 3 9s, 27. Use all that figure. So we've got nothing left over. So we've got a figure of 209. The key here, or one of the key learning tips here, is we were trying to put 3 into 2 and it doesn't go. So rather than just ignoring it, we say that it doesn't go by putting a 0 in our answer, and we carry that 2 over to the next figure. I'm going to rub that one out. I think just gives a bit more space. And the final kind of example that I'm going to mention in terms of division, because it's something that's another sort of key learning point, is let's say those 2 figures went in neatly. So we had 48 in the first one, 209 in the second one. You might remember from school or advanced that you might do remainder numbers. I'm going to look at that now. And there's 2 possible ways of doing this. So the calculation I want to do is, so here, 482 divided by, which we show by this little bus stop, 8. Okay, so the first thing we're going to do is number 8 go into 4. Well, 8 doesn't go into 4, so we know we've got a 0. Don't necessarily need to put the 0 there, but it just shows that I've worked that out. We haven't used any of that 4, so we're going to carry that 4 over here. We now need to look at how many 8s go into 48. Well, I can tell you that's 6. That's a nice round figure. That's 6. And we've got all of those 48, so we don't need them anymore. We've now got a problem in that we want to put how many 8s in 2? Well, we know it's 0, but we haven't used this 2, so we've got a 2 left over. So there's 2 ways that we can look at this. We've got the answer of 60, so we know it's 60 and 2 left over. If we look, it's actually 2 lots. Oops, it's 2 out of 8, or 2 divided by 8, or whatever you want to talk about, because that was the calculation we're doing. Well, when we write 2 out of 8, we normally write it as a fraction, like that. If you remember from the fractions webinar, we can actually simplify that down. 2 8s is the same as 1/4. If you're not sure about simplifying, then we can send you the fractions webinar afterwards. So our answer actually is 60 and 1/4, and that's using the 2 that we've got left over here. So we can leave the answer of 60 and 1/4. There is another way to do it though. So if I just undo this, I'm going to make a note up here that we got the answer of 60 and 1/4, and hopefully you'll see why I'm writing that in a moment. So we did our 8s into 4 didn't go, 8s into 48 go 6, and then our 8s into 2 again doesn't go, so we know we've got 0. We've now got 2 left over, and although we've got nothing written here, actually, as you know in numbers, we could put a decimal point, and this could go on forever and ever. We can have 0, 0, 0, could keep going forever and ever. So we can just put a decimal point and put some zeros afterwards. Because we put a decimal point in the question, we need to have a decimal point in the answer in exactly the same spot. So let's put that in again so we don't forget it at the end. We said 8 doesn't go into 2. That's where we've got this 0 from, this one here. So we haven't used this 2, so we can carry it over to here. We can now look at how many 8s go into 20. Well, 2 8s make 16. So we know we can get 2 in there. We've used 16, which means out of this 20, we've got 4 left over to carry over. And if we do 8 into 40, that's 5. So our answer now is 60 0.25, which is actually, this 0.25 is exactly the same as a quarter. Think of 0.5 would be a half, so 0.25 is a quarter. So whichever method we use, we get the same answer. Just in the first one, we did it with a remainder 2/8, which we simplified to a quarter. In this one, we've actually worked out the actual number of it is 60.25. Now, again, we could go this route. There could be, it could be 8 into 79.321. And that's obviously will go a long way down the line until you've got no numbers left. Again, don't expect them in the test to give you that, because that's not a realistic calculation to expect you to do. Something like that, where you're working out a number and a quarter or a half or 3/4, is certainly possible to do. One thing I've kept relatively simple calculations. You probably don't agree that they're completely simple, but you could have, let's just take our figure we had before, 482 divided by a 2-digit figure. So let's say 13. Again, there's more than one way of doing this. Personally, I would suggest you just keep the 13 as a whole. So all you're going to do is how many 13s go into 8, how many 13s go into 48, and so on. Because you probably don't know your 13 times table, I certainly don't. Most people generally can work up their 1, 2, 3, 4, 5, 7, 8, 9, 10 times table, or use their fingers for it. 13's a bit more awkward. If you are dividing by 13, before you start the division, it's worth just writing in the corner 13's times table, just work it out. And I haven't done this before, so I'm going to try and do it as we go. So it'll be 13, 26, 39, 52, 65. Let's do a couple more. 78. That should give us enough. So we've got 1 13 is 13, 2 13s is 26, 3, 4, 5, and 6 13s. So if we were going back down here, let's just write this a bit neater, and we're doing 482 divided by 13. Well, how many 13s are in 4? None. We know there aren't any 13s in 4, so we'll carry that over. We now need to work out how many 13s are in 48. Well, we can straight to our grid on the top right corner, and if we look, the nearest number below that is 39, and that was 3 9s, so we can put a 3 in there. We know we use 39, so 39 to 48 gives us 9 left over. We now have to do 13s into 92, so I didn't go far enough with my calculation. But by having them written on the right-hand side here, I can easily refer to them rather than having to remember my 13 times table. As I say, you might want to do that with all times table, but I'd suggest if they're smaller numbers, you'll probably be okay. But if the question is using 2 numbers, let's go back to where we were to start with. So if it's 482 divided by 13, you still just, rather than taking the 8 as a whole, you just take 13 as a whole. I say there is a method you can do where you split 1 and 3 up, but I personally think that's even more confusing, so I'll leave that as 13.